Hi everyone, welcome to the Code Ninja Spaces. Today we have really great and interesting news to share with you guys. So starting with AI is hitting the coordination limit. So there's a lot of talk about multi-agentic AI system replacing teams. So but recent research suggests that these things are becoming bottlenecks. So what exactly did DeepMind discover here?
So it's a recent report, and what DeepMind report is showing that a multi-agent system is when multiple AI agents work together. Each agent handles a subtask, and collectively they try to solve a complex problem. In theory, this should scale linearly, and in practice, it doesn't. So DeepMind found that when agents coordinate without a central authority, small mistakes compound across agents, causing errors to amplify over 17x. And when coordination is centralized, what it means is when agent or a controller orchestrates the entire system, error amplification drops to 4.4 or 4.5x. So what it means is, in agentic systems, if you have a centralized authority or an orchestration layer, that helps you achieve your sub goals better with the agentic system than if you don't have those, if you don't have that centralized agentic orchestrator. So that's what this report shows, and I also feel like that's pretty much how humans operate. Like someone probably is incredibly good in achieving something individually, but that not necessarily mean she or he is good in coordinating the entire team and managing the team and then achieve the final goal. So probably these digital beings are following the same mantra. So yeah, that's what this report shows.
So perfect. Moving on, models are improving faster than benchmarks. We keep hearing that AI models are getting better, but this time Anthropic shares that 2% per month their models are improving against SWE benchmark. This is huge. So what's your take on this?
So first of all, Rafael, SWE benchmark or software engineering benchmark is a benchmark that tests whether AI models can solve real software engineering tasks, not just toy problems. And here's something very important: a 2% improvement month. So generally, what happens is uh, we think of AI as one explosive uh, achievement, but that's not happening. What's happening is the models are getting better every month. So for example, it's about Anthropic. A 2% improvement month over month means a lot when you see how this compounds over a year. And that's what we are seeing is that models probably a year have just 2% improvement month over month, but from last 1 year, they have improved a lot. And if you just plot it for the next 2 years, you would see where it goes. So that's what DeepMind launched Facts. It's a benchmark that designs to test what models actually know, not what they can pattern match their ways to passing tests. So this is about Facts is about we. So when we talk about SWE benchmarks, we just have these examples where we just pattern match these models to see if they can solve certain problems or not. But there's SWE benchmark was not actually designed to see whether the models can perform real coding tasks. So now Facts by DeepMind is actually a step towards that. And how can we evaluate that these models can solve and actual software problems? Think of it as like GDP valves. So I mean, in the last month, we did something on GDP valves where OpenAI introduced how can we measure models' performance in actual GDP growth. So
Yep.
that's things like it's a DeepMind fact is something like that, but specific to SWE-bench.
Perfect. So we talk a lot about softwares, but science is being automated at the hardware level as well. So Google DeepMind is building an automated material discovery lab in UK. Focus areas are around semiconductors, solar cells. So I feel like personally, this is a huge shift. Like AI helping scientists to AI doing science. So what do you think? Is this a fair
You
forming?
know, yeah, I think it's accurate, not just fair. I think, I mean, this is my passion. I mean, applying
Yeah.
AI into the physical world is something I'm very passionate about. Like, for example, how certain material works. Uh, Now, when we talk about material formation, I mean, one way to look at is like you use, let's say, X-ray crystallography or some of these techniques, these incredibly sophisticated techniques to understand how certain materials perform in certain conditions, in certain weathers. But with AI, I mean, you don't need these sophisticated apparatus. What you can see is you can predict that how this material would have performed. So, for example, think about protein folding. I mean, there's no real. We currently don't know how exactly these protein folds, but our guess with AlphaFold 3 is so good that it's closer to the actual reality. So that's what basically the lens to see when we apply these models into material design. I mean, and by the way, material design is incredibly important. For example, space flight, rocket design, chip design. So when so this I mean, I know DeepMind has a history, but I'm pretty sure that that's exactly the lens DeepMind is applying here. Even if you see that the term they've used, hypothesizes material. So
Mhm.
what hypothesis can we take about this material, right? And then AI is very good at it. It's very
Mhm.
good in predicting what probably has been happening under the surface in this material. So I am very excited about this.
Wow, that's huge, bro. Like from software to hardware, we really often talk about taking bet against UI, that chat is the new UI. So there was something really interesting. What does it mean when people start using AI chat as a primary health advisor?
So if you see, I mean, let's take health. I mean, you talk about healthcare or health. So think about it. Health. I mean, when you talk to your doctor, that's still chat, right? Most of the 80% of the our interaction with the doctors is chat, right? So I see people talk a lot about that. I mean, AI is still, it's just a chat bot. I mean, your doctor who you pay, for example, $100 just to visit, or if you talk about Pakistan, 5,000 rupees just to see whether what's happening in your, let's say, with your skin and all. It's still a chat, right? So
Hmm.
our interaction with humans or with other intelligent species is a chat. So and with AI's preferred UI as a chat is a huge moonshot, I would say. And this is not about just replacing, let's say, doctors. It's about being the first line of reasoning. And if you talk about for builders, this means UX is collapsing into a language. Just think about it. I would again say it. UX is collapsing into a language, and products that don't speak. Honestly, Rafa, I mean, you've been working on Hyper for so long, right?
Yeah.
I mean, I asked you, like, uh, the more voice you would
Hmm.
include in the product development, the better it would be. So products that don't speak won't survive. Mark my words, they won't survive. Voice is the language, is the interface,
Hmm.
and chat is the interface. Even for technical products, that has to be there. So again, I would say this is so important.
Hmm.
Again, because I know you've been involved in UX circles. So again, I would say UX is collapsing into a language, and
Hmm.
products that don't speak won't survive.
Even those designers do fight with us regarding that, but still. So okay,
Well, of
moving
course,
on, we talked about
that
software, UI, hardware. So let's move toward physical infrastructure. Physical infrastructure is actually moving at the speed of machine, I guess. This is a huge shift, like from software optimization to the physical world optimization. How we look towards that?
I think one of the biggest uh, shifts we would see is uh, building AI systems for the physical world. So, for example, if you know Palantir,
Yeah.
ShipOS reduced a 200 or Navy production workflow to 12 seconds. Just think about it. I mean, at the end of the day, it's a software. When we talk about software, what is software? Software is intelligence compression and
Hmm.
correlation, right? I mean, imagine you without a software, what does it take to build a ship? Let's say it takes a year, and with the software, let's say it takes a month. Do you
Hmm.
think it's a good idea to deploy software for ship manufacturing? Of course, what Palantir has shown us is like that. It's an incredible idea that you can. I mean, just imagine reducing a 200 Navy production workflow to 12 seconds. That's what software for physical world means. Both in not, I mean, of course, Palantir involved mostly in defense workflows, but apart from defense too. So I think this means your supply chain, your defense, your healthcare are being retimed to machine clocks, not human ones. So countries that adapt win, countries that don't, of course, they would become dependent.
These things are taking us towards the capital stack as well. This is a big statement to say that silicon is eating the capital stack. Like what does it mean when memory costs more than logic on GPUs?
Ah, so I mean, what it means is compute economics have flipped. Of course, we
Hmm.
used to optimize logic. Now we optimize data movement, uh, uh, and this means hardware design, cloud economics, national infrastructure strategy. So yeah, I mean that is uh, so what the real equation to look at it is, like as Elon says, like intelligence produced per gigawatt of
Hmm.
energy spent. So at the end of the day, the real metrics to look at is, I think in your last podcast, I've also shared that the true lens to look at it is like with energy, it's an important part, software and knowledge work. These are the three levers to drive meaningful growth. Not just chips alone, not just software alone. They just would work uh, uh, across and in collaboration to make sure that we would be able to solve some important problems. So that's what it means. Jensen also talked about this a lot.
Hmm.
I mean, for example, Tesla is using Grok to design chips. Now, think Grok is a software and chips. I mean, hardware. So it means applying AI to the physical world. Oracle is investing a lot. I think there's more than $500 billion of a backlog that is Oracle is investing in chips. Supermicro, and I remember Supermicro and XAI is building gigawatt scale data centers in Memphis. And when we talk about data center, Rafa, what it means is to power a data center, a small nuclear reactor is required. Just think of this that way. So it's the amount of the capital that is going into hardware and into software, into knowledge work is just insane.
True, I do agree. More in GPUs means more energy, more resources. So what does climate and geoenergies, are we now engineering the planet itself? I'm curious, like, where we are going.
So think about it. I'll give you one. I mean, of course, as I said, it's intelligence. The real equation is intelligence produced per gigawatt spent. That's the equation. So intelligence is related to the energy spent. And what is intelligence? If you ask what is intelligence, again, I would quote Elon. It's information compression and correlation, right? So we need a lot of energy. Think with a nuclear reactor, small nuclear reactor that powers a data center, you can power 1.2 million homes with that, right? So it means we need a lot of energy to power these data centers. But here's my take on this, on energy, because there's a lot of people who oppose this much of investment in data centers, and the idea is that probably we don't have that much energy for our households, and then why we're spending that much into data centers, and billionaires, they're doing it. But let me share one thing with you. So orbital compute, we are bringing data centers into space. Think about it. Space has lots of energy. There is sun is 70% more intense in space, right? It's 24 hours. There's no, so it means sunlight is available 24 hours. There's no night. So it means there are no batteries, right? And then, why do we need this energy here on Earth for the data centers? The reason for that is we need cooling system, right? So we need a lot of energy to cool down these data centers on space. All you need is a radiator at the back of the data centers, and you don't need a cooling system. So that because space is absolute zero already. And also, what's the last thing you need in space is, what's the last thing you need for building these data centers is like how you going to connect these clusters is currently what you do is like fiber optics, which is basically laser in a fiber, right? This is on planet Earth, this is the fastest way to communicate between the racks. Now, what is the way? But is there a faster way, even with the fiber optics through which we can communicate racks? Yes, it is laser through vacuum, and that space is vacuum. So I can assure you that if it's an incredibly hard problem, but maybe in next few years, if we are able to set up orbital compute, mark my words, we would have this problem of energy on the planet Earth would be solved. No one would have access energy, because that was the first time we would be harnessing sun energy and powering all that to power these intelligent species. So I think, yes, in the shorter run, we need energy to power these data centers. So, for example, if you see lots of energy is going in Texas, we're building lots. So then in Riyadh, because they have excess energy, they can produce lots of energy through oil. But real capex is going to space. So yes, in the shorter run, there's a lot of energy demand. In the longer run, I don't think we have energy shortage. We have access of energy. And I would also like to share one important scaling, Kardashian scaling. What it means is, so how do you measure whether civilization is how advanced a certain civilization? So so Kardashian was a Russian scientist, and he had this like the best way to measure it is like how much of the planet's energy has been put to a useful work. That is basically a scale you can tell whether the civilization is advanced or not. And I think if you see that energy is the most important thing, and now we are putting that into useful work. I guess that's my take on energy. So I'm not looking into from that doomer's lens that we have less energy. We have a lot of energy.
Oh, that's great. I was listening to Elon a few days ago, one of his summit in Riyadh related to any investment. He was saying we soon gonna have AI from space, like AI specifically for space as well.
And you would be using it. What it means is like you would be processing major intelligent operations in the data center, and you would be communicating directly from space to your device. Now, it's nothing. It looks crazy, but Starlink. it is in more than 140 countries, I guess, and most of the people who are using it is basically they've been connected to satellites. So I know it looks crazy, but if you know how we are moving towards space, what's the progress, I think it would be crazy in the next 10 years if we don't do it. It is
Yep.
going to happen.
So true. So far, it's a great conversation talking with you. So that's it for the today. Thank you. We'll see you next week.
Thank you. Cool.
Bye.